Assalamualaikum and hello everyone. Welcome back to the new video of 2.3 electronic configuration. So in the last video, actually I've mentioned about we're gonna learn the rules kan, but actually in this video kita akan belajar the rules itself. Okay, so we have learned actually how to write down the electronic configuration in terms of orbital diagram as well as in terms of SPDF rotation. Okay, so how we're gonna write it down is mostly based upon our Aufbau principle, Hund's rule dengan Pauli exclusion principle. Okay, so maybe there are certain part yang macam we can see the flow itself yang n equal to 1, f to 0. We're gonna fill up the electron by the orbital itself, but there are actually some cases lah. Okay, why the electron must be opposite spin, why it must be filled singly first. That is actually based upon these rules. So let's look on your notes on page 18. Okay, so here I mentioned electron configuration shows how electrons are arranged in the orbital. Okay, so for the first rule that we're going to learn is actually for the Aufbau principle. Okay, so here is actually siapa yang tulis nota tu, yang ni kena tulis juga Okay, so how do I get here? Okay, remember that when n equal to 1, L only could be equal to 0, so 1s. So kat sini when n equal to 1, the possibility dia 1s sahaja. When n is equal to 2, L could be equal to 0 and L could be equal to 1. So the possibility for when n equal to 2, we could have 2s and 2p. So that's why kita dekat sini. When n equal to 3, L could be 0, 1, 2. So it means that we do have the possibility 3s, 3d, 3p, 3d. So here n equal to 3 and so on, n equal to 4 and n equal to 5. And the orbital itself, memang maximum we're gonna learn is actually f orbital lah when L equal to 3. So that's why lah memang 5 ni dia tak ada 5. Sebenarnya ada 5G lagi, tak silap. But then for our ni kita nak tengok SPDF, or particularly kita akan tengok SPD lah sebenarnya. Okay, so he mentioned the electrons occupy atomic orbitals in order of increasing energy. So here, what does it mean is that when we're gonna write down, we're gonna fill up our orbital, dia ada arrangement dia. So first kita akan penuhkan arrangement dia. Kita buat macam arrow ni, 1s. Okay, so satu first possibility, kita akan arrange through 1s dulu. Next, kita akan buat yang ini. Next adalah 2s. Okay, after that, kita tengok dulu, kita buat arrow ni 2p, 3s. Okay, so jadilah 2p, 3s. And so far that is what we're going to fill, which orbital that we fill in based on the previous video yang example. Memang kita ikut this arrangement lah, 1s, 2s, 2p. Okay, so next what we're going to look at is next 3p, 4s. So 3p dulu, baru 4s. Okay, and then next lagi dia ada 3d, 4p, 5s. Sini ada 3d, 4p, 5s, and so on. Okay, so based on the previous example, what I've explained is actually tadi kita tengok example anti-lithium sahaja kan, 3s. Okay, but then when we look here, actually for example, if the number of proton is n equal to 20, ini is very important lah. Okay, so actually when we look, if you look based upon here, you thought it will be 1s, 2s, 2p, 3s, 3p, 3d. But it's not. Actually, the energy of the electron in 3D, the energy of a 3D orbital is higher than 4s. So that's why we're going to fill up our electron by 4s dahulu. Later, we're going to finish up by 3D orbital. Okay, so this is the example. Yang ini for this, nak guna colour apa? Okay, for this blue colour is actually, remember, yang ini I'm just going to write down based upon here. The maximum number of electron depends on which orbital. So kalau s orbital, maximum dia it must have 2 electron. So any s maximum dia is actually 2, regardless of what is your n. 1 ke, 2 ke, 3 ke, 4 ke, 5 ke. Memang for s orbital, electron the electron occupied, the maximum electron occupied is 2. Kalau P, we have 6. Okay. So remember why 6? Because we have 3 orbital. Each orbital boleh isi 2 electron only. Okay. Next, kalau D, maximum dia sebenarnya 10 electron. Okay. So sebenarnya this is the arrangement. But then, when you gonna write it down, nanti kita akan tengok when we're gonna learn about the electronic configuration of transition element. Yang ni tu baru kita kena arrange follow the trend of n. So maknanya kalau kita isi nanti dia jadi 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2. Okay. So memang betul we're gonna fill up the 4s2 first. But then if the electron in d orbital is occupied, kalau 1 ke, 10 ke, 9 ke, we have to write it down before the 4s2. So nanti kita kena rearrange balik lah. Kita jangan risau, kita akan tengok during the electronic configuration of our transition element. So that is actually based upon your Aufbau principle. So that's the first one lah. Next we're gonna learn is actually our Hund's rule. So here it mentioned that the orbitals of equal energy must be filled singly with parallel spin before pairing occur. So for example, what does it mean by the orbitals of equal energy? So maknanya we're gonna talk about kalau 2p kan, we have 3 orbital kan, 1, 2, 3 orbital. So what does it mean here? It actually has the same energy. Okay, so kat sini dia kata must be filled singly with parallel spin. So contohnya if we have 2 electron, contohnya dekat sini what we have is actually 2p2. So di sini we have 2p2. Okay, remember it must be filled singly, maknanya kita kena isi dia sorang-sorang, dia single dulu. Okay, so bila dah yang ini it could not happen, yang ini kita salah lah. Why? Because it's actually dia dah tiba-tiba terus pair up, so salah. This one is the correct one, filled singly first. Okay, next, yang ini example dia, contohnya Miss bagi dia adalah 2p3, 2p3. Yang ni pun salah sebab dia dah pair up dulu. Actually must be singly filled. So sini X, sini betul. And then here we have berapa elektron? 1, 2, 3, 4. So 2p4. 2p4. So yang ini pun salah lah. Sebab kita nak dia must be singly filled first. So maknanya dia ada 1, 2, 3. Lepas tu ada lagi satu elektron, barulah kita buat yang bawah ni. So actually it could be double headed boleh. Nak jadi apa ni? Singly headed arrow pun boleh. Tapi sebenarnya senang lagi kalau singly headed arrow lah. Okay, so this is for the example itself. So contohnya, alamak tak cukup ruang. Okay, Miss buat kat bawah ni So contohnya if I have 3D6. Contohnya I have 3D6. So kalau 3D, so jadi 1, 2, 3, 4, 5. Okay, so 3D. So again, how we're going to fill it up? We're going to fill it up by singly first 1, 2, 3, 4, 5. Then baru kita 6. Dia macam tu. Must be yang ni. Dia tidak boleh. Ni baru betul. This one betul. Kalau yang salah punya version, sini. Convert pula. Copy paste. Copy paste. So contohnya kalau kamu buat 3D6 kan. So kalau kamu buat macam ni, dia jadi salah lah. Dia kena singly fill first. Dah cukup 5 ni, baru yang ni. Kalau D orbital memang ada 5 lah. 1, 2, 3, 4, 5. Kalau P orbital, we only have 1, 2, 3. Sebab lukisan kita pun PX, PY, PZ. Ada 3 orientation of orbital. Kalau D orbital ada 5. DXY, DXZ. Faham lah Malas ni mesti cakap. Okay. So that's the second. The last rule that we're going to learn is actually the Pauli exclusion principle, where it mentioned that there are no 2 electrons in an atom can have the same 4 quantum number NLMS. Okay, so what does it mean is that only 2 electrons may occupy the same orbital and they must have opposite sign. Okay, orbital tu maksudnya setiap satu each one of your box ataupun each one of your platform tu lah macam ni. Yang ini. So, why? Okay, so kat sini. Why only 2 electrons could occupy the same orbital and they must have opposite spin? Okay, why? So, contohnya dekat sini, and here is actually our 1s orbital. So, when it is 1s orbital, so it means that n equal to 1, L equal to 0. So, m dia memang possibility dia satu sahaja equal to 0. Okay, so remember, the electron spin is actually, we only have positive half, negative half. Positive half tu, so selalu masukkan dia sebagai senangnya upright punya position lah. Kalau yang negative half tu usually we mention as downward position. So, kalau contohnya for example it has the opposite spin, so it means that for the NLMS kita, even though your N, L and M is the same, but then your S tu different because kalau upright positive half, downwards negative half. Okay, so it this obey the Pauli exclusion principle. So for example we have here. So yang kat sini ada 1S ni, okay, betul, the NLM memang 100, and the 1 because the first shell L equal to 0, your S orbital, and your M memang equal to 0 lah when L equal to 0. Tapi dalam case ni both of the electron is actually upward, so it can't be so dia punya S is some the S dia is actually the same, which is positive half, which cannot be the same because Pauli exclusion principle mention it cannot have the same quantum number. Macam tu lah. Contohnya for example kamu takkan sama dengan jiran kamu, kamu takkan sama dengan best friend kamu. Actually memang kita masing-masing ada different identity. Maybe ada persamaan, so contohnya kat sini maybe ada dia punya similarities here, but actually dia mesti ada something yang make you unique gitu. So itulah. Okay, so contohnya here we have an LMS. So contohnya dekat sini yang ini for this part is actually it could be yang ini acceptable because they have opposite spin. This one cannot because actually both of it is the same spin. So contohnya kalau yang ini S equal to half, ni pun S equal to half, this one pun S equal to half. So it can't be. Yang ini S equal to negative half, ini S equal to negative half. So cannot. Remember, each one of us is unique. So cannot ada yang sama lah. Dia macam boleh ada yang sama tu, but not 100% is the same. Macam tu lah. Okay, so the last part ni, yang ni yang lain pula. Yang ni 3 elektron pula. So we know that for each of the orbital we can only have 2 electrons. Sebab kalau contohnya sini positive half, ini negative half, yang ini negative half juga. Mana boleh? We can only have 1 positive half, 1 negative half. So ini pun kira salah. Okay. So that's the 3 rules that we have learned, which is applicable when we write down the electronic configuration. Okay, so yang ini is a bit of summary. So contohnya kalau kat dalam nota tu kamu boleh tulis kat bawah, here, down here, or I'm gonna write down in a sticky note, kamu paste pun boleh juga. So here kat sini Miss nak paste lah. Yang ni I have written down beforehand. Okay, so actually we have learned there are 3 rules that we learn this part. First one is actually Aufbau principle. Aufbau principle, where we learn that the electron is occupied in the order of increasing energy. So 1s dulu, 2s, 2p, 3s, 3p. Okay, yang ini yang lain sikit. 4s dahulu, baru 3d. Okay, that's for the Aufbau principle. Next, for the Hund's rule is that the electron must be filled singly before pairing occur. So dalam case ni electron is equal to 4 pada p orbital kita. Yang ini Miss tak labelkan, is just a general one. Make sure each of the electron ni single dahulu. Once semua dah single, once it is occupied fully, barulah kita ada pairing. So yang ini, for this one it cannot. This one is incorrect because actually dekat sini kan sebenarnya boleh singly fill dulu. Okay, and last but not least is the Pauli exclusion principle, where the electron in the same orbital must have opposite spin. Because each of the electron must have their own identity. Each of the electron have their own quantum number, different, dia unique gitu. So kat sini this one is correct. Contohnya ini S orbital lah, it will be 1s ke 2s orbital, where dia kena ada opposite spin ni, S equal to positive half, yang ni kira S equal to negative half. So that is actually the conclusion. Okay, lepas ni kita akan tengok the examples pula. Okay, so that's it for this video.